When we're looking at combined gas laws, again, although we can solve these problems algebraically, often an intuitive approach is actually easier, and I'm going to discuss both. The combined gas law, remember, is just a question of taking the Charles law and the Boyle's law and putting them together. And basically your law, remember, is P1 V1, that's Boyle's law, divided by T1. Now I've included, you can think of it as either Charles' law, V1 over T1, or Gay-Lussac, P1 over T1, equals P2 V2 over T2. In other words, we're saying here that when I can start with a given volume, pressure and temperature of one gas, and then I can change something. I can change its pressure and find a new volume if I didn't do anything to the temperature, or I could change its pressure and temperature and find a new volume. And usually those are the kinds of questions that are asked in Chem 51. So, for example here, if I wanted to find a new volume and I wanted to rearrange algebraically, the solution here might be as a first step, to move the P2 to the other opposite side of the equation by dividing both sides by P2. That would give me P1 V1 over T1 now P2, because I divided both sides by P2. That makes P2 go away on the right-hand side, leaving me V2 over T2. And then in a second step, I can now cross-multiply, i.e. multiply both sides by T2, and that gives me P1 V1 T2 over T1 P2 now equals V2. In other words, it's the usual drill here of trying to isolate one variable. And notice I always tell people to isolate, to move the variables around. Don't put numbers into a problem like this and move the numbers. There's also an intuitive way to solve this kind of a problem. And that is to say that a new volume would of course have something to do with the volume I started with. And it's a ratio of pressures, and which way would I write my pressures? And again, if I thought of this and just gave myself one chance, for example, what if I had a volume and I doubled the pressure? What's going to happen to the volume? You should intuitively know the pressure, the new pressure, which would say be twice the old pressure, makes the new volume smaller. In other words, the V2 would be smaller than V1 if I make P2 bigger. So the only way that can work is to have the bigger number down below and the larger number up top. Notice if I'd asked this the other way around and said, well, what if I had a volume of gas and I have the pressure? Well, I know the new volume, V2, would be larger. So notice again, I still have to put the new pressure, the half pressure, down below, because some number divided by half makes it bigger, in fact twice. So it always ends up being V1 times a ratio P1 over P2. Same on the temperatures here. I know that if I heat a gas, it makes the volume bigger. So if T2 were bigger than T1, that would work that way. Or if I chill a gas, it makes the V2 smaller than the V1. That still works if I put the T2 over the T1. And if you look at the previous equation, the algebraically manipulated, it works out the same way. It ends up being P1 over P2 is one ratio, and T2 over T1 is the second ratio. So however you do that is going to work out the same. So whether you do it algebraically or intuitively, and I'm going to go through this intuitively when we go through this problem to emphasize exactly what I mean, it's going to come out the same. So say we have a balloon, a weather balloon or something like that, at 25 degrees Celsius, and the pressure is 750 millimeters of mercury. That's a pretty conventional pressure. And the volume is 10 liters. And let's say it rises to the height such that you have a new pressure, so we'll call that the second pressure, of 0.351 atms, and a new temperature, we'll call that T2, of minus 55 degrees Celsius. Now, there are two things about this question. First, I gave you one pressure in millimeters and the other in atmospheres. You have to have pressures consistent in a ratio type calculation. It doesn't matter which way you do this, but I'm just going to say, let's ask what the first pressure was in terms of atms. So, remember we said that I'm going to ask what the second pressure was in terms of atms, and that would be given in terms of millimeters mercury. So if I had 0.351 atms as my P2, and I use the ratio 760 millimeters of mercury over 1 atm, that gives me basically 267 millimeters of mercury. Notice, if I had wanted to take P1 and turn that into atms, I could have done that too. All I care about is I either compare a ratio of atms or a ratio of millimeters, and I've just worked this out. I just chose to do a ratio of millimeters. The other question is temperature. There's no options on temperature. both temperatures must be expressed as Kelvin. So my first temperature is 25 degrees Celsius plus the 273 conversion factor, which comes out to 298 Kelvin. And the second temperature is minus 55 degrees Celsius plus 273, which comes out to 218 Kelvin. Remember, there is no temperature, absolute temperature, less than zero. That's any more than there's a length or a mass less than zero. So now I've got what I need. I've got my data in the proper set of units. In other words, I have an initial pressure, and I chose to do our pressures in millimeters, so it's 750 millimeters of mercury. I have a second pressure that we have figured out to be 267 millimeters of mercury. I needed those consistently. I've got a new temperature here, an initial temperature of 298 kelvins, and I chilled this balloon, and so the new temperature here is 218 kelvins. And now I want to find the volume. Well, again, my suggestion is look at this in an intuitive way. You're starting with a 10-liter balloon. I'm cutting the pressure. What happens when you reduce the pressure of something? Doesn't it get bigger? Of course it does. So that means I'd have to have the ratio 750 millimeters of mercury over 267 millimeters. If I set the ratio the other way around, that 267 over 750 would be less than 1, and less than 1 times 10 makes a smaller volume. That doesn't make any sense. Notice I'm applying this ratio without giving any thought to the temperature yet. It's a separate issue about temperature. Now, in the case of temperature, I've taken a balloon at 25 degrees and put it in an environment where it's now minus 55. I would expect the balloon to get smaller, shrivel. So just as if you put a balloon in the refrigerator or in the freezer, it gets a little smaller. So the ratio here has to be 218 Kelvin over 298 Kelvin, because that's the only way I can make the V2 smaller than the V1, ignoring pressure rather. Notice these two effects, the pressure effect and the temperature effect, are going in opposite direction, and which works out all depends on how the numbers come out. In this particular case, it comes out to 20.5 liters is the final volume. Notice and recall, when you're using your calculator here, if you're doing this with a calculator, you'll type in 10.0 times 750 times 218, then go divide 267, and again divide 298. Remember, that's always the way the calculator works in those kinds of arithmetics. And in those, every number below the fraction bar is preceded by the divide operator. Now, if you had decided to do this algebraically, you would have manipulated as I did up above, and you would have had V2 equals P1 V1 times T2 over T1 P2, and you could have plugged in the same numbers. The P1 here was the 750 millimeters of mercury. The V1 was the 10.0 liters. The T2 was the 218 kelvins. And down there below I have the T1, and that was the 298 kelvins. And the P2 was that new pressure of 267 millimeters. If you look and compare, you can see all the numbers are in the same place. And of course it comes out to 20.5 liters. So there's no difference in which way this goes in that sense, whether you do it algebraically or intuitively. I think intuitively makes more sense because you can stop and think at each step what effect a particular change, environmental change, is having on your balloon. And using logic, you'll never make any errors. But if you want to rely on the algebra, that's fine. But just make sure you manipulate symbols before you plug in. Don't put all those numbers in there and move them around. That makes it much more complicated.